back to Let's Learn Together. I am George Yusuf. In this video tutorial, what I want to do is print the contents of AX register. So whatever value we have in AX register, we want to print it out to the screen. So let's check what we can print in AX register. I'm going to go to the calculator and I'll go to the binary and put 1, 2, 3, 4 bits, 5, 6, 7, 8 bits, 9, 10, 11, 12, 13, 14, 15, 16 bits. So that's what we can put in one 16-bit register. FFFF is in hexadecimal. In decimal, the biggest number is 65,535. So that was 5 digits. 65,535 is 5 digits. So we'll start first with simple 1 digit in AX register, whether it's from 0 to 9 or 3, whichever number we'll do. What I'm going to do is create a label called 1 digit. What does this do? I'll move that number into DL, move to DL, AL, and then I'll add to it 48, add to DL 48, and then call print char label below. What does this do? It puts 2 in AH, calls interrupt 21 to print that value in AX register, which is number 3. Let's test that. I'm going to run it in full speed. Number 3 is printed, as you can see down here. Okay, now let's add another digit. Let's say 3 and 4. So how we're going to do that now is basically what 34 is. If I was to divide 34 by 10, you will have 3 result with a remainder of 4. Remember, we've talked about this before. If you are to do a division or multiplication of a 16-bit register, you have to 0 DX register. So let's do this. I'm going to say move into DX register 10. Okay, let's assume I have a number just to show you in DX. I'll say move to DX number 2. Then I'll put 10 in BX and then divide AX by BX. I'll say divide BX. What do we have? Let's test it. Now 34 is in AX, it's 22 in hexadecimal. I'm going to put 2 in DX register. This is 2. Now when I divide AX by BX, I put 10 in BX. When I divide AX by BX, it puts the remainder of 4 usually in DX register. But since there is a number in DX register, which is number 2, it's simply going to add that remainder to the value that we have in DX. Check this out. 4 plus 2 is 6. This is why we have to 0 DX register before we do multiplication or division of 16-bit register. So before I do a multiplication, I'm going to say XOR DX with DX. Now let's test it. Divide BX. 34 divided by 10 is 3 in AL, and the remainder 4 is in DX register. Now we can start printing the number from left to right. So in other words, we'll start with 3 first, print it to the screen, and then 4. So to print number 3, all we have to do is put it in DL, which will override number 4, add 48 to it, and then call print character to print it. But we're going to lose number 4, so we have to save this register DX before we do that. So let's do that. What I'm going to do is right after, I'll say push DX to save it to the stack, and then call, since we know how to print one-digit number, we'll simply call one digit to print it for us. Once it comes back, prints number 3, we're going to pop AX, the value that we pushed to the stack, the remainder was 4, I'm going to pop it in AX register, and then again call one digit to print it for us. When it comes back, I'll put a return there to end the program. So let me run this in full speed. 3 is printed, but not 4. Let's find out why. I'm going to single step. So 3 is printed, return. Oh, so there's no return in this label. I have to type return over here. Now we can run it. It never got back to this point to pop AX and call the next label. So I'm going to run it in full speed again. 3 and 4 is printed. Well, let's name this label 2 digits. Now, if I increase this to 3 digits, I'll type 5, 3, 4, and 5. Let's delete that. What we're going to do is create another label called 3 digits. What does that do? We're going to do the same thing, XOR the X with the X. I'll move into the X to number 10, and then divide the X. Once it does that, I can say push dx, because we're going to divide 345 by 10, which will give us a result of 34 in AL, and with 5 remainder in dx. We're going to save that to the stack to come back and print it later, because we're going to start printing 3 first, and then number 4, and then number 5. But here, notice what we have here. I have 3 instructions right there that are being repeated, exactly the same over here. So instead of repeating these instructions, I'm going to create a label down here at the end. I'll call it divide by, or divide 16-bit register. Does that do? XOR dx with the X, move into BX10, and then divide dx and return. So it goes back to what it was called, to the caller. So I'm going to delete this portion too. Over here, I'll say call divide 16 bits. Do the same thing over here. Call divide 16 bits. Once it comes back, I'm going to push the remainder to the stack. And since if we push number 5 to the stack, now we have 2 numbers left. Since we know how to do that already, we have 2 digits label that did the same thing before. We can simply call 2 digits to process that for us. Once it comes back, we need to pop whatever value was pushed to the stack in AX, which will be 4, and then call 1 digit to print that 1 digit for us. When it comes back, type a return to end the program. So let's emulate this and run it in full speed. Should print 3, 4, 5. 3, 4, 5 is printed. Cool. Now let's add another digits. I'll say 6, and this will be 4 digits label. And this will do the same thing. I'll call divide 16-bit. And then when it comes back, I'll push dx to the stack. Right? now that we push number 6 over here to the stack, what we have left is 3 numbers, 1, 2, 3, 3, 4, and 5. So what we can do is simply call 3 digits to print that for us. When it comes back, we'll do the same thing, pop AX, and then call 1 digit label this time. When it comes back, we'll give it a return to end the program. So let's emulate and run it in full speed. 3, 4, 5, 6 is printed. I add another number, 5 digits. Now I can create another variable called 5 digits, and we'll do the same thing. I'll call divide 16 bits and then push GX to the stack and call, since 7 is pushed to the stack, what we have left is 4 digits, right? 6, 4, 6, 5, 4, 3. We're going to call 4 digits label to print 4 digits for us. Once it comes back, I'll pop number 7 back into AX, then call 1 digit to print that for me. When it comes back, we'll give it a return to end the program. Now let's emulate and run in full speed. 3, 4, 5, 6, 7 is printed. And whatever number you put in, it should work same way. I'll say 5, 6, 8, 8, 9 and emulate and run. 5, 6, 8, 8, 9 is printed. Now check what happens if I go back to 1 digit now. Emulate and run. I get 4 zeros preceding my result. Oh, that doesn't look good, so we have to eliminate that, although it's the correct result, but it does not look good. What I would like you to do is just to go through the program yourself, emulate and do single step through the program to find out why is it printing these zeros. Well, a way to eliminate that would be is to create some checkpoints over here. We're going to compare these values. Well, I'm going to say compare first AX with number 10. Okay, and I'm going to say jump it below. So is AX below number 10? It is in this case. I'll jump to 1 digit to print it. After that, I'm going to compare again to AX to 100. Jump it below to 2 digits. So if it's below 100, which would be anywhere from 10 to 99, it should jump to 2 digits. So I will jump all the way to 2 digits right here, print the 2 digits for us. And the next comparison we'll do compare AX with this time 1000. I'll say jump it below. If it's below 1000, that means 999 or below. Jump to 3 digits. And then I'll compare again AX with, add another 0, 10,000, and jump it below. If it's below 9,999 and under, jump to 4 digits to print it for us. Otherwise, if it's not 1 digit, 2, 3, or 4 digits, then it must be 5 digits. It will continue downward processing this label. So now if I run this with just 1 digit in AX, there are no zeros preceding the number, just 5 by itself. Less 5, I'll do 6, 7, 3 digits, emulate and run. 5, 6, 7, printed. I cannot do 8, 9, can I? 8, 9, is this smaller than 65,000? Yes, so I should be able to print that. Run. 5, 6, 7, 8, 9, print it. Thanks for watching, and if you enjoyed this video, please hit the like button, and I'll be seeing you hopefully in the next video tutorial. Have a good day. Bye bye now.